Okay, I want to build an AI assistant, one that can answer questions, check information, and even take actions. But now I have a bigger question. Which model should I choose? There are so many options, different models, different capabilities, different providers, and the choice actually matters. Because the model I choose will directly impact how my agent going to behave. So, how do I choose the right model for the right scenario instead of just guessing? What if I had a single place where I can explore, compare, test models before using them? That's exactly what Microsoft Foundry comes in. If you are wondering how to choose models and use them to build intelligent agents, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI Copilot and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching and training experience. This course covers 12 sessions, where we'll dive into core AI concepts and Azure, and learn how to turn ideas into real applications using modern tools like Microsoft Foundry. In the fourth session, we will see how to get started with generative AI and agents in Azure. I will show you how Microsoft Foundry helps you discover, evaluate, and use AI models to build real applications and agents. Up to now, we have talked about models, agents, and how they work together. Now let's answer a very practical question. Where do these models come from? And how do we choose the right one? That's exactly where Microsoft Foundry comes in. Think of Microsoft Foundry as a curated marketplace and delivery platform for AI models. Instead of randomly picking a model and hoping it works, Foundry gives you a catalog where models are clearly described, categorized, governed, and delivered in a safe, enterprise-ready way. You are not guessing, you are choosing intentionally. At Microsoft Foundry, we provide two big model categories: models sold directly by Microsoft and models from partner and community. Models sold directly by Microsoft are models that are hosted by Microsoft and built through your Azure subscription. They come with enterprise support and SLAs, follow Microsoft Responsible AI standards that we talked about in a previous session. These include all Azure OpenAI models and selected models from trusted providers that Microsoft manages directly. For example, if you are a company building an internal HR assistant and you want enterprise security, predictable billing, and Microsoft support, you will typically start with Azure OpenAI models in Foundry. The partner community models gives access to models from research labs, open source communities, and specialized AI providers. These models are provided by trusted third-party partners, purchased under the partner's terms, and are useful for niche or specialized use cases. For example, you are building an AI system for medical imaging or legal document analysis. A partner or community model may be a better fit than a general-purpose language model for some specific scenarios. Foundry doesn't just list models. It helps you compare them intentionally based on real decision factors. And let's break those down. First, deployment type meta. Where the work happens. This answers questions like, where is your data processed? How is the model hosted? How do you pay for it? For example, a public customer-facing chatbot may use a fully managed cloud deployment. A sensitive internal tool may require stricter hosting rules. The second factor is versioning and updates. This depends on your preference. Do you prefer stability or do you prefer innovation? Models evolve, and Foundry lets you see the model version, whether it is auto-updated or stay fixed for consistency. For example, if you are in a finance or healthcare, you may prefer a fixed version. If you are experimenting, you may welcome automatic upgrades. The third factor is about the rate limits. This is all about how fast and how often. Every model has limits, such as the maximum tokens per minute and the throughput constraints. So, for example, a high-volume customer support bot needs higher rate limits than a small internal assistant. The last factor is about guardrails and responsible AI policies. And this is critical. Foundry models come with built-in responsible AI policy, content safety control, and usage guidelines. For example, you don't want your AI assistant generating unsafe or inappropriate content. Foundry helps apply guardrails by design, not as an afterthought. Now that we understand models and agents, let's look at how we actually use a generative AI model in practice. And the most important rule here is simple. Before you write code, you experiment. That's exactly why Microsoft Foundry provides the model playground. Think of the model playground as a sandbox. It is a safe place where you can try different models, test prompts, adjust settings, and see results instantly, all without writing a single line of code. For example, you want an AI to help employees write professional emails. In the playground, you can type or write a polite email asking for a deadline extension. You see the result immediately. Tweak the wording and refine the tone before you build anything. Why the playground is so valuable? Because it helps you to test prompts by understanding what works and what doesn't work. Tune parameter by controlling tone, length, creativity, and also capture configuration by saving exact setting before coding. This avoids a very common mistake, jumping straight into code and debugging prompts at the same time. When you work with a generative AI model, whether in the playground or in code, you always configure three main things: instructions, input, and parameters. Instruction or system prompt sets the rule and the rules for the model. Think of it as giving the AI a job description. For example, for an HR agent, we would tell it, "You are a helpful HR assistant. You respond professionally and clearly. You don't give any legal advice." This frames how the model behaves. Next, we have input or user prompt. This is what the user actually asks. Good prompts are always clear, specific, and context-rich. For example, rather than write an email, in the prompt, you would say, write a friendly email reminding a colleague about a meeting tomorrow at 10 a.m. This prompt will get you a much better result. Finally, the parameters. The parameters is all about how the model responds. Parameters help fine-tune the response by using factors such as creativity. If you put it low, you will get a precise, predictable answers. And if you put it high, you will produce a more creative, varied response. Another factor is the response length, like a short or maybe a long or maybe more detailed explanation. So what is the best configuration for the factors? This depends on the context. For example, for a legal summary, low creativity is better. And for marketing copy, high creativity works well. Once you are happy in the playground, moving to code is straightforward. For example, let's look at this without diving into technical details. In the slide, you have a typical Python example that includes an endpoint where the model lives, an API key to authenticate securely, and a prompt submission in the input. The same prompt you tested. What is important to know, the exact same concept apply in Python, JavaScript, C# or any language. Only the syntax is going to change, not the logic. And yes, you use OpenAI or APIs through Azure and Microsoft Foundry to consume these models in code. Up to now, we have been working with generative AI models, testing prompt, tuning parameters, and understanding how models generate responses. The natural next step is turning a model into an agent. That's exactly what the Microsoft Foundry agent service is for. What does creating an agent really mean? In simple terms, a model answers questions. An agent is designed to get something done. When you create an agent in Foundry, you take a model configuration that works, save it as a named agent, give it persistent instruction, and finally connect it to tools and knowledge. So the agent doesn't forget its role every time you talk to it. One key difference from models is that agents remember who they are and what they are supposed to do. Their instructions act like a job description. What they help with, what tone to use, and what they should not do. This makes agent consistent and reliable across conversations. For example, you create an agent called Project Assistant with instructions like, you help me track project progress and prepare clear status report. You do not make business decisions. Every time you use this agent, it behaves consistently. It doesn't forget who it is. Agents are not limited to what's in the prompt. Using the Foundry agent service, agents can search for knowledge. For example, project files, document, internal data sources, or approved web sources. For example, instead of you pasting content into a chat, you can ask, what were the main decisions from last week's meeting? The agent searches the meeting notes and extracts the answers. This is data search for knowledge, not guessing. In addition, agents can take actions. This is where agents clearly go beyond models. Agents can use action tools to automate tasks such as sending emails, creating summaries, updating records, or generating structured output or code. For example, a meeting assistant agent can read meeting notes and then generate a summary and finally send it to participants. Just like with models, Foundry gives you a safe agent playground where you can test your agent's instructions, try different tools, see how it behaves, and fix issues early, all before connecting it to real system or writing code. Once your agents behave the way you want, now you can connect it to your application and start consuming it via APIs. Just like models, you can connect to your agent using the Foundry Project API via secure endpoints and authentication, obviously. Again, from an app perspective, agents are consumed through APIs, exactly like models. The difference is what the agent can do once it gets requested. To summarize what I have said so far, creating an agent with the Foundry agent service means you start from a model that works, you add persistent instructions, you connect knowledge and tools, you enable automation, and finally, you still consume everything through APIs. And one more time, remember, models answer questions while agents help get the work done. Now let's do a quick exercise where we will continue our discovery of the Microsoft Foundry portal. We will experiment with the deployed model in the playground, and then we will observe the effect of system prompts and also the parameter. Finally, we will create an agent with the file search tool. You can also practice this exercise in your own environment by accessing the lab steps in the link that you can see on the screen, or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go! In this exercise, we're going to use Microsoft Foundry to deploy and explore generative AI models. And we're going to look into the agent, knowledge tools, how to answer questions, and so on. So here's starting from the Microsoft Foundry portal. And we are staying in the same project that we created in the previous session. We are going to also use the same model. So if you haven't done so, you can get back to that session and see the demo of how we could possibly create an agent from the discovery box. And then you will find your model ready to be used. So here's the GPT 4.1 mini model that I'm going to continue with and use in this project that focus on agent. You can also practice your own in your own environment, the exercise lab, that you can find the steps in the AI-901 course. So once we have our project ready, our model ready, well, let's start out working on our agent. Now here I'm clicking on my model, and which is the GPT 4.1 model that we created before. And I'm going to try out with, talking to the model, see how it behaves. So how was, for example, Ada Lovelace? I get an answer, information about who is that person. I can see that it used the model GPT 4.1 mini. I can see also all the information that I needed, from the model to the time spent to the token used, and also I can copy the result or maybe delete all this discussion and answer that I get. If I look at the token, I have two things. You can see the input, the output. The input depends to your prompt, to whatever you're going to feed the model, and also the output depends to the answer that you get from the model. So let's keep up the conversation. Let's ask it, tell me about her work with Charles. So here's, it detected that I'm still talking about Ada. So give me information about Ada and Charles and their work. And I can see also the result here for the token. It's different. So you see the input is a little bit bigger because also we have the discussion history. The output is a little bit longer. So the output is also a little bit bigger when it comes to token. Now let's start a new chat. So now again to ask, tell me about the Elisa chatbot. So it's providing me the information about the Elisa chatbot. I see the information here. I see the number of token used. Input, again, shorter. No history discussion. Output a little bit longer. We get a little bit longer output in here. I can keep up the conversation. I can say, how does it compare, for example, with modern LLMs? And see if it's going to keep up the discussion and follow up or connect the conversation with the Elisa chatbot that we talked about it previously. So you see here, Elisa and modern LLM, and give me a longer comparison here. Also, we have a table, comparison table, which is great. And you can see also for the token, how much the response token get. You also have here, you can see here the code section. So in the code section, so if you are a developer going to really start coding, well, you need to look at the code section. And in the code section, you can see at the top, we do have different configuration that you could change or work on to see the code or the piece of code that reflect the configuration that you're going to put in place. To start, we have the API. So we have the completion and the response API. There is two. We have also the language. Here we are selecting Python. We have other language. We have the SDK, also using the OpenAI SDK. And also these three dots help us to do more configuration related to, for example, authentication. And whenever you put the configuration, it's going to be reflected in the code. For example, here, if you change between the completion and the response API, it's going to be different, really. The completion is really broadly used programmatic syntax for submitting prompts to a model. The response is more newer syntax that offer greater flexibility for building app that can converse with both standalone models and also with agents. If I change the language, so for example, from Python JavaScript, I can see that also here the code changed a little bit. Also, if I basically look into the piece of code, so when we start here for this with Python, I see from OpenAI, import OpenAI. So the first thing, we are going to import the libraries. And then we have two information that we are putting in place, the endpoint, and the deployment name, and also the API key, right? But the API key, you can change it here. From three dots, you can change from the API key to using intra. So that's something that you can do. Here also, we are interested to the client. So you can see here, for the client, I'm using OpenAI, and I'm grabbing that information. So the base URL, which is the endpoint, and the API key, I'm providing really the API key, right? Then I have here selected the completion API. So it's going to be reflected also down, which is the completion. So as here I'm getting the completion that's going to receive the result. We have here, I'm using the client, really chat completion create method that takes the model, which is the one that configured, the deployment name GPT 4.1, and the message, it composed of two things when it comes to completion, the role and the content. The content, it has, like you can see here, what is the capital of phrase, which is the prompt, and the role here, I put in the role is the user that is asking question. If I change this to really response API, here's the piece of code going to change. And the difference here is the method that we are using and the method how it acts with the rest. So you can see here, I'm using client response create, and I'm putting the model and the input. Then here, if you look into the three dots, you can configure the authentication method. So we have seen the key. Now let's look into the intra. So when you use the intra with the token that you get from the intra with the Azure identity, you see first thing that is going to change is the library that you load. So where from Azure identity, import default Azure credentials, and also we have get bearer token provider. So the libraries that we need to import when we work with intra ID and tokens. So here's with the intra ID, the client app is going to represent really the authentication and token based or an identity that is assigned to it. So you can see here, I'm getting the token provider. I'm using the get bearer token provider using the default Azure credentials. And when it comes to the client, when I call it, the API key is going to change here to token provider rather. That we have seen it previously, that we provided with the default Azure credentials and the get bearer credentials. That's it changed with the connection. And also we have seen there is also that link the Azure AI that I'm showing in here. So you can configure whatever it's more convenient for you. So response API, client API, the language when you do your own demo, so you can play around this two configuration and put it on whatever is more helpful for you. If you select, for example, here the rest, so you can see here we have a curl call. And if you stay with the OpenAI SDK, it's going to be the piece of code with the call of OpenAI SDK, like we have discussed previously. Let me go to really Visual Studio Code to see this piece of code and try to play a little bit on it and modify it a little bit to see how we could possibly in real project work on this. I'll just setting up the environment now. When everything is ready here and the environment is ready, you can see our workspace. We can see that it shows a little bit some information related to Azure AI Foundry. And we can really start using or trying out our model. So you can see here the model that I have, the connection to the Azure credential, the token provider, the rule, the content, etc. And now let's move to Foundry to configure or change a little bit our solution to have some more system prompt instruction. So now I'm moving it to, rather than an AI assistant, to something more helpful. So here I'm saying that you're going to be a helpful AI assistant who are going to support expense claims and also provide like concise, accurate information only on this topic. We're going to ask it the first question: what kind of business expense are typically reimbursed by employers? And here's we have like more information about this, like so some from the web generic information answer about what we can do. So if I ask it, for example, something out of the scope, for example, tell me about the Elisa chatbot, it's going to tell me I'm here to assist only questions related to expense claims. So here's really we made our agent specialized to specific tasks. So all the change that I made here in the code doesn't really appear. So the code is just giving you like an idea of what you can do. But if I want to like have a specific change, I need to change them myself in the code itself, okay? I need to change things in the code itself to make things more, looks like more what I'm expecting. So for example, here I can include a section instruction that I wrote the same instruction that I put before, plus I put the input, which is the prompt, that specific prompt that I want to execute, the user prompt. So once I'm happy with all this, I can save it as an agent. So I can just click the button Save it as an agent, and I give it the name. So I'm going to really name it our expense agent. So I'm going to create it and name it expense agent. And I just save it to start using it as an agent. Yay, now it's created. So I see it took the instruction that was expected. And here, interestingly, previously we had only chat and code, but now we do have a section called YAML. And now let's look into this really YAML section, what it does contain within it. So this here, it contains really the definition of our agent. So it does include the model, the parameter settings, and the instructions that we specified in here. So you can see here, this kind of prompt, we have like the model GPT 4.1 mini. So if I look here, for example, in this definition here, you can see we have the first thing we can see here, the kind is prompt, the model GPT 4.1, instructions, the instruction that we will route, you are a helpful AI assistant. So the same instruction that we would route in here. We have also some other useful information like the temperature. We have also the topi and the different tools. And in this case, we are using the web search, basically. You can also look into more information that it does exist. And also you can search if you want to add more in the documentation. Here we have a useful button where we can configure the parameters. For example, the temperature, we can see it controls the randomness. So lower interpretation means that the model will produce more repetitive and deterministic response, or increasing it, the temperature will result in more unexpected or active responses. You can see also have the top T. This is similar to temperature, but it is control the randomness, but use different method also. So it depends how you configure it. Lower or higher are going to change the behavior, the general behavior of your model. You can see also the text format, text, JSON object, JSON schema, and also you can choose when you use the tools always, or the model decide when to choose it. So let's start with some prompts here. So I'm going to ask it, basically, who are you? So it says I'm an AI assistant specialized in employee expenses claim. So I know who it is. We can ask it things like, how much can I claim for a taxi? So it depends to your company expense policy. That's what it says. So here we do understand that it really needs some, it needs some data to be grounded from the company data. So we need to give it some company data to be able to do that. And for that, we can do it through the tools. So here's we can really upload some company data through uploading a file that is going to help with the expense policy. So we're going to browse for a file. So I'm uploading my file. It's a Word document that has expense policy. Now it's going to index it. It has been indexed, so it's ready. So this is my file is ready. So I having some expense policy information about taxis, meals, entertainment, and so on. With the guidelines also. So once I'm happy with this, once it really prepared, created a new index, the vector index is there, I can attach it and start using it. Now I see here I have it a file search, you can see it. And let's see the reflex of change that happens to our agent. First thing, I'm going to remove or edit the web search. So you can see here the search web Bing or search specific domain. And when I go to the add, here I have the option to deactivate the web search. Now I go to the YAML file to see the changes that happened. So you can see here in the tools section, we do have a specific type here, which is the web search, right? Once I save, this is going to change. So I'm going to reflect here whatever happened in here. And also in the YAML file, I can see the tools, we have other thing. It's not the web anymore. It has a type, which is a file search, okay? So here's my tools, type file search. We have the vector store for IDs. So it reflected the change. So previously it was a web only, and now it reflected the change. Also, it's going to reflect it when we do some prompts right now. So let's start new chat. Good, always good to start from fresh. So how much can I claim for a taxi? Now we're reflecting like $500 getting from that file doc that we created. Also, it's going to reflect the change in the tokens when you upload a file and you have more accurate search. So what about the hotel? So also give me a precise information. Also, a good option that we have here, we can preview our agents. So if I click preview agent, so I have like a web browser way to interact with my agent. So I can say like, how do I submit an expense claim, for example? I'm going to provide me information. And this information is coming from the knowledge that we do have in our solution. And also you can see your code with GitHub. So you have also these options here with the preview. So why not now focusing on the code part? So you can see here that we do have a code section. Here, the language is focused on C#. So if you are more C#, this is how it looks in C#. We have also possibility to change it to other language, for example, Python, since we are talking about Python from earlier. So you can see here the piece of code with Python. So here we do have first the library. So from Azure Identity, we grab the default Azure credentials. And we do have Azure AI Project and Power AI Project Client. Again, we need the endpoint. So we also, in the project client here, we have the AI Project Client that use the endpoint and the credentials. And for the credentials, here it's using the default Azure credentials. Here we have an agent. So my agent is really our expense agents. This is the number of the version that I have. So I see exactly the name of my agent, which is expense agents. And here we can see for the response, which is reference the agent to get a response here. So here in the response, we see that we are calling Open AI Client Response Create method, taking the input here, which taking the role user, right? And the content we are saying, asking like the prompt, tell me what you can help with, for example. We also have other information like the agent reference, the name of the agent, also the version of the agent that we are providing it to this same method. Now let's move to Visual Studio Code. We're going to set up the environment. Now that is ready, we have here the instruction markdown file that show us how to work with this agent. So step by step, open terminal, do this, and to run your agent locally, you can execute Python run agent command. So I'm going to copy this, run agent.py. You can have also see the possibility to update your agent configuration. So you can see here the left-hand activity bar, open the Azure AI Foundry tab. Under resource, expand the agent section and click corresponding, click open YAML file, make any changes, and then update the changes in Azure AI Foundry. So you're really well guided with this instructions file. Now getting to our agent. It's the same piece of code that we have seen previously with all the information that we read it so far. So the only thing here we should do is really running this agent. So let's start by clicking clear to just have a clear terminal. So I'm going to paste the command line and see the result. So okay, here, how to submit an expense claim correctly, eligibly, etc., etc. So it's answering the user prompt that we have here. So we can change it to something else. So for example, here we already ask question like, how much can I ask claim for taxes? So I can take this prompt and paste it over here. Obviously, you can put this as a parameter of your solution, but here we're trying just to make things easy. So here's again running the agent. And you see, you can claim up to $500 per trip. So it provides me really information accurate, dependent to the resource information from the Word file that we uploaded. That's it for your demo. I hope you enjoy it. In this session, we discussed how Microsoft Foundry helps us discover, compare, and safely use AI models, experiment with them using a playground, and ultimately turns them into agents that automate tasks by combining instructions, knowledge, and actions. Remember that all this material is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue your learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!